Alright, so this is section 5.3, which is on homogeneous equations with constant coefficients. Such equation takes the form an times the nth derivative of y plus an minus 1 times the n minus first derivative of y, and then until a2 times y double prime plus a1 times y prime plus a0 times y. Because it's homogeneous, so the right hand side is equal to 0. So recall that in section 5.1, we know how to solve this equation in the case n equal to 2. So this is a generalization of what we did in section 5.1. So the step 1 is the same. We need to solve what's called a characteristic equation. So the characteristic equation has the same coefficient as the original equation, but instead of the derivative of y, we have r to the n minus 1, r squared, r, and then 1. Right. But in section 5.1, n is equal to 2, so this is a quadratic equation which we know how to solve. But now n is larger, so we first need to learn how to solve the equations with degree higher than 2. So let's learn how to factor polynomials. With degree greater than 2. Okay. So in reality, not polynomials factor, but in our homework and exams, the polynomials given to you are definitely going to factor. So let's recall two important facts. So if you plug in a number into a polynomial and it turned out to be 0, then the x minus c is a factor of the polynomial. So all we need is just find numbers to plug in the polynomial. If it's 0, then we have found a factor. And then now we have to figure out which numbers to plug in. So the candidates for roots of the polynomial are plus minus a over b, where a divides the constant term and b divides the leading coefficient. Alright, so let's do an example. So let's consider p of x equals to 2x cubed plus x squared minus 13x plus 6. The leading coefficient is 1. No, it's not 1. It's 2. And the constant term is 6. So the candidates for roots are plus minus 1/2, plus minus 1, plus minus 2, plus minus 3, and plus minus 6. So all we need to do is plug in these numbers and then see if it's equal to 0. So let's first try 1. P of 1 is equal to 2 plus 1 minus 13 plus 6, which is definitely not 0. This is negative 4, which is not 0. So it does not work. Now let's try 2. So if we plug in 2, we get 16 plus 4 minus 26 plus 6. This is equal to 0. So 2 is a root. That means x minus 2 is a factor. Once we found a factor, we can use long division to find the other factors. So let's try to divide 2x cubed plus x squared minus 13x plus 6 by x minus 2. So we have 2x squared here, 2x cubed minus 4x squared, 5x squared minus 13x, this is plus 5x, 5x squared minus 10x, negative 3x plus 6, minus 3. So it's negative 3x plus 6, 0. So p of x is equals to the factor we found, x minus 2, times 2x squared plus 5x minus 3. This is a quadratic, so we know how to factor it. So now we can fully factor this quadratic polynomial. So it's going to be 2x and plus 3 here, minus 1x here. All right. So now we have fully factored p of x, and then we found all the roots are 2, 1/2, and -3. All right, so let's do a different example. So let's consider a degree 4 polynomial. So let's consider x to the 4th plus 2x cubed minus 2x squared minus 3x plus 2. So the leading coefficient is 1, and the constant term is 2. So all the candidates, there are not many candidates here. So the candidates are plus minus 1 and plus minus 2. That's it. So let's first try 1. So p of 1 is equal to 1 plus 2 minus 2 minus 3 plus 2, which is equal to 0. So this works. So that means x minus 1 is a factor. So we can use long division to divide p of x by x minus 1. Let me make this faster here. Minus here. Plus x, x squared minus x, negative 2x plus 2 minus 2, negative x 2x plus 2, 0. Alright, so we have factored x minus 1 from p of x. Now we have to factor this thing on top. So the candidates are the same, still plus minus 1, still plus minus 2. I'm going to save you a little time. I'm going to plug in 2. And I know it works. So it's going to be equal to 8. Oops, I meant negative 2. So if we try x equal to negative 2, then what we get is negative 8 plus 12 minus 2 minus 2, which is equal to 0. This works. So that means x plus 2 is a factor. So again, we can use long division to divide this cubic by x plus 2. X squared plus x squared plus 2x minus x minus 2 minus 1 negative x 2, 0. Okay, so now we have fully factored p of x. So p of x is equal to x minus 1 times x plus 2 times this thing, which doesn't really factor. So the roots of p of x is going to be 1 and negative 2. And this is quadratic, so we can use quadratic formula here to find the roots here.